Hello, gentlemen. Today we're working on factoring ax squared plus bx plus c. In this case, the a value is not 1. So we've looked at x squared plus bx plus c when the a value is 1, and today we're looking at when the a value is not 1 or is greater than 1. All right, we're jumping right in. The general form of a trinomial is ax squared plus bx plus c, or standard form. For this trinomial, 2x squared minus 3x minus 7, the coefficient, or the numerical coefficient of a, or of a is 2, b is negative 3, and c is negative 7. That is our a value, b value, and c value. If we're going to factor this fully, and this is just a review from last day, if we're going to factor fully, we look at what we have here in common. We've got a binomial 3x plus 1. There is a 2x being multiplied by 3x plus 1, and a negative 7 is multiplying by a 3x plus 1. So what we do is we put what we have in common first, and 3x plus 1 is being multiplied by a 2x and by a negative 7. And of course, if you FOIL and you distribute, however you like to think about it, you will end up with this exact same answer. If you expand either of those, you'll end up with the exact same quadratic in standard form. I'm just going to erase these arrows here so that I can have room in the next line. Factor by grouping. You recall when you're grouping, we have 4 terms here. And what we want to do is when we're grouping is we want to group the first 2 together and the second 2 together. And what we're going to do is remove the GCF from each. So when I look at the first set, I have x squared plus 3x. Numerical coefficient, the numerical coefficient of the x is 1. And the greatest common factor between 1x squared and a positive 3x is technically a 1x. So we just write x for proper form. So we could take an x out. And again, there are 2 strategies here. You can think of taking x squared and dividing it by x. X squared divided by x is x. Or you can think of x times what, in this case x, will get me x squared. There's 2 ways of thinking about what to put in that bracket first. So x times something is x squared, or I can take my x squared here and divide it by the GCF to find out what goes inside the bracket. Let me erase that for some clarity. Okay, so x times x will get me x squared, and x times what will get me a positive 3x. In this case, it will be plus 3. So if you look at that, x times x is x squared, x times positive 3 is 3x, and I've accurately represented my first binomial. And I'm looking at the second binomial, 7x plus 21. What I have in common here is a positive 7, and then if I multiply 7 times x, I will get 7x, and times positive 3, I will get positive 21. 7 times x is 7x, 7 times 3 is positive 21. Now, one of the key ways of understanding or knowing that you've kind of like a quick check to know that you've done it right so far is that you have x plus 3 in brackets and x plus 3 in brackets again. That comes in handy when you're dealing with subtraction or negatives and you want to remove a negative. Sometimes you want to make sure what you have in the brackets is the same thing, and that'll help you. In this case, we're going to write what we have in common first. We have an x plus 3 in common, and then we have x plus 7. Let's fix that up. X plus 7. And then you're done. Factor by grouping. Identify 3 types of trinomials studied to date and give an example. So one of the easiest ones that we should recognize is a perfect square trinomial, because we're looking at types of trinomials. Perfect square trinomial, I think one of the common ones we've used in our lessons is x squared plus 6x plus 9. Right? We may have taken a peek at a different version of this. We may have had a 2x squared plus 12x plus 18, so that if I remove the greatest common factor 2 from this, I would end up having this in brackets. And so I have a perfect square trinomial once I take out the GCF. we've looked at x squared, for example, x squared plus, let's say 8x plus 7, okay, where it's not a perfect square trinomial. And then we may have looked at examples like this where we have a numerical coefficient in front of the x greater than 1, so 3x squared, for example, plus 24x plus 21, where you need to remove, in this case, you need to remove a 3 as your greatest common factor, and then you would end up with something like this that you can factor. And when we factor the second version, we look at two numbers that multiply to 7, in this case 7 times 1, 7 and a 1, and add up to 8. Well, 7 plus 1, positive 7, and a positive 1 is 8. And so you factored that by saying x plus 7, x plus 1, something like that. And for the perfect square trinomial, we know that when we factor a perfect square trinomial, it looks like vertex form. So in this case, x plus 3 squared, just to recap. I know I didn't ask you to show the factored versions, but that's just a recap of what we learned today. To recognize that the learning goal here is to recognize that not all trinomials can be factored. And you remember in some of the seat work that the questions asked you to factor if possible. And so today we're going to look at one option when it appears that it's not factorable, how we can still find another way to factor. So in this case, we're looking at trinomials in the form ax squared plus bx plus c, and the a value, a is greater than 1. Okay, or we could have a is less than 1, dealing with negatives, but first we're going to deal with positive values for a. And we want to look at, when you look at this one here, 3, 8, and 4, for example, I don't have a greatest common factor. There is no greatest common factor between 3, 8, and 4. So again, you might look at 3 is 1 times 3. The factors of 8 are 1, 8, 2, and 4. And the factors of 4 are 1, 4, and 2 times 2. And so these have something in common, but 1 and 3, there's no 2 here. So I'm kind of stuck. I can't take out a GCF. So what do? I look at what it says here. It says to factor trinomials of the form ax squared plus bx plus c by finding two integers whose product is a times c and whose sum is b. So I'm looking at a times the c. So a times c in this case equal 3 times 4, which is equal to 12. And so then I have a product of 12, and I need a sum of b. In this case, b is equal to 8. So what two numbers multiply to 12 and add up to 8? Well, if you look at the factors of 12, you know 1 times 12, 2 times 6, and 3 times 4. And 2 times 6 is what I'm looking for because that adds to 8 and multiplies to 12. And what you're going to do with that is you're going to rewrite the trinomial. But instead of writing 8 plus 8x here, well, I'll do this for now. I'll show you what we'll do. We are going to rewrite this 3x squared. Instead of writing plus 8x, we'll write plus 2x plus 6x plus 4. So all we've done really here is we've changed 8x to be 2x plus 6x. That's what we have. And now we recognize from previous examples and even in today's lesson, what we can do here is we can factor by grouping, and we're going to group those two. So again, we didn't really change the question. We just broke down the middle term to say 2x plus 6x by using that strategy of multiplying 3 times 4 to get 12 and finding out what two numbers multiply to 12 and add up to 8. So they multiply to 12 but add up to 8. And that's what we've done here. So our next step will be to remove the GCF between 3x squared and 2x, and the GCF is x. So x times 3x will get me 3x squared, and x times a positive 2 will get me 2x. Again, that's the way I think about it. X times 3x will get me 3x squared. But you may prefer to think of it as 3x squared divided by x. What does that get me? That's the quotient rule, correct? So 3x squared divided by x squared, and then you would 3 divided by the imaginary 1 here. 3 divided by 1 is 3, and x squared, oops, I apologize, I think I put an exponent there and I shouldn't have. 3x squared divided by 1x, so 3 divided by 1 is 3, and x squared divided by x is really x squared. You subtract the exponents, so I'm left with 3x. And that's what I have here as my first option. Or you may just think about it as x times what, fix that up, x times what will equal 3x squared. Well, in this case, x times 3x will get me 3x squared. So that's how I think about it. Well, whatever works for you, that's what you should be using in your head. So x times 3x plus 2. Now in the second set, I have 6x plus 4, and the greatest common factor is a positive 2. Don't forget to write positive 2 here. So a positive 2 times 3x will get me 6x, and a positive 2 times a positive 2 will get me 4. And as you remember from homework and from what we did above, you write what's in common first, and what's in common first is 3x plus 2. That's my check. I know I'm doing the right thing. And now I have x plus 2 are both, x and a positive 2 are both being multiplied by 3x plus 2. And that's your final answer. Let's look at this next example here. We have 10x squared minus 19x minus 15. And what I want to do, I want to see, do I first have a GCF? No. So we're always looking to see if there's a greatest common factor. In this case, there isn't. 19 is a prime number, and we know that 10 has the factors 1 and 10, 2 and 5, and 15, we know 5 times 3 is 15, so we know that's not a prime number. This is not going to work out. What we're going to do is multiply 10 times negative 15, which is a times c. I should put that in here for you just as an example. So a times c is equal to 10 times negative 15, which is equal to negative 150. So we're looking for numbers that multiply to negative 150, and b is equal to negative 19. So it has to add up to negative 19. And the only numbers I know that do that are a positive 25 times, in this case, we're going to multiply 25 times a negative 6. That'll equal negative 150. And in this case, 25 plus negative 6. Apologize. That was a complete mistake. This should be the negative. That's negative, and that's positive. How do I know that? Because my sum total must be a negative 19, not a positive 19. So in this case, it has to be a negative 25. Let me correct this. A negative 25 and a positive 6. So negative 25 plus positive 6, or negative 25 plus 6 is equal to negative 19. So I've now confirmed my two numbers are negative 25 and a positive 6. So we're going to rewrite 10x squared minus 19x minus 15. We're going to rewrite that, but we're breaking down the middle term. The negative 19 will no longer be negative 19. It'll rather be negative 25x plus 6x minus 15. So all we've done is broken down that middle term and using the negative 25 and a positive 6. And then we're going to look at the first two and the second two binomials, and we're going to what we call factor by grouping. So the greatest common factor between 10x squared and negative 25x is, and again, you can pause the video here and try this on your own to see if you're doing it correctly, is a 5x times 2x and 5x times a negative 5 would get me negative 25x plus 3 times 2x minus 5. I'm just taking a quick look to see if what I have in brackets there is the same binomial, and it is, so I'm on the right track. Builds up your confidence while you're doing your work. Then you have 5x plus 3. We're done. What I'd like you to do here is try two examples on your own and then bring them to class. So we have 6x squared. Try this one. And then the second one I'd like you to try is this one. And there we go. I'll draw a line here. So that's what we want to look at right now. Okay. We'll see you in class.